Welcome to today's episode on the Minds of Machines channel. In this session, we'll dive into creating a neural network from scratch using Python and the NNFS library. We'll start with a simple example of calculating the categorical cross-entropy loss, which measures the performance of our predictions. This tutorial is perfect for beginners eager to grasp neural network basics. Let's get started.
Now let's start understanding from the code perspective. So here first we will import the Python library math in this code. The math module which provides various mathematical function, example usage of math.log which returns the natural number logarithm of 10. So this is an example of what math module does in Python. Then next we will be defining the Softmax output, in which we will be declaring three values, which is 0.7, 0.1 and 0.2. The line defines a list representing the output probability from a softmax function, which we had learned in the previous tutorial. Is a neural network in which suppose we have three classes and the model predicts 70%, 10% probability of class 2, 20% probability of class 3, and the sum of probability is always 1. So this is how the softmax output we have declared, but when we sum it up, it will always be 1. Then next we define the target output, which is 1, 0, 0. So this line defines the true label using one hot encoding. In this example, 1, 0, 0 is the means the first index 0 is the correct class. The other class indices 1 and 2 are incorrect, and if the correct class was second one, it would be 0, 1, 0 and so on. Then we define the losses. So loss equals to sum of log of softmax output into target output 0, 1 plus the same math log of softmax output 1 into target output 1 plus math log of softmax output 2 into target output 2. So this is the formula for calculating the loss. This line calculates the categorical cross-entropy loss. Let's break it down. The zip underscore output softmax output pairs up the corresponding element 1, 0.7, 0, 0.1, 0, 0.2, and the first comprehension of, for example, t multiplied by math log of p for p in up to any values does the following thing. For each pair of t, p, the t is the target 0 or 1, as we have written it as the target output, and p is the predicted probability. So the predicted probability in our case is 0.7, 0.1, 0.2, which we had defined, and it calculates t into math log of p. So that is the target value is actually multiplied with the math log of the softmax output, and this effectively selects only the probability for the correct class where t is equals to 1. The sum function then adds up all these values, and the negative sign at the beginning makes the loss positive, since log of probability is always negative. So that's why we have seen negative value. In this case, only the first term where t is equals to 1 contributes 1 into math log of 0.7. The other terms become 0, and two terms, which is the class 2 and class 3, as it multiplies with the target output, which is defined as 0 and 0. So the loss will be minus math log of 0.7, which is around 0.3567. Now we can print and see how the loss, what the value of the loss is, as I have defined while explaining the loss formula. So as you can see, it's 0.3567. So this you can basically use or predict how good your model is with loss cross entropy formula, which requires softmax output and the target output, and when you multiply it and summon it, it will actually tell what amount of loss or how good our model is or how good our neural network is. So this is the first part of this tutorial, in which we are seeing how we calculate the loss using cross entropy formula.
Then we'll generate spiral data to train our network. Our neural network consists of two dense layers. The first layer with ReLU activation to introduce nonlinearity, and the second layer with a softmax activation to output class probabilities. Finally, we'll compute the loss to evaluate our network's accuracy. Let's get started.
Now let's understand how we use the cross entropy loss function in our neural network in the second half of the code. So first, as usual, we will be building in this tutorial also the neural network from scratch. So first I will be importing the NumPy as usual, NumPy library, first the math library, then the NumPy library as NP, and it is imported for numerical operations. Then we will be importing the NNFS library, which is usually used for neural network implementations. Third, we will be importing a nnfs.dataset, in which we will import the spiral data. The spiral data is a function to generate spiral data set for classification. Once we have done that, next step is to initialize. In this stage, we will be initializing the NNFS in the form of nnfs.init function. This initializes the NNFS library, likely setting random seed for reproducibility. Then we will define the class layer dense, and inside which this class basically represents a fully connected layer, inside which we will initialize weights randomly and biases to 0. So how it is done? Create the init function in which we will define self inputs and neurons. Then we will define the weight, which is equals to 0.10 into np.random function of n inputs and n neuron. Then, as I mentioned, we will set the biases to 0. Then we will be defining a forward function which computes the output of the layer using matrix multiplication, which can be in the form of self.output equals to np, which is the library provided by Python, dot of inputs into self weight, and then we add the biases. Once that is done, we will do the ReLU activation. So the basically, as I've explained in the previous tutorial, here we are implementing the rectified linear unit activation function. It basically returns the input if it is positive, otherwise 0, in order to basically remove the negative number. So what we will do, we'll define a forward function in which we will have self and input, and the output is equals to np dot maximum of 0 and the inputs. After that, we will define the softmax activation function that basically converts the probability that to the sum 1, so that we can predict the output in better way, which also I have explained in the previous tutorial of what it does. So we will define the forward function in which we will take the self and input, Then we will get the exponential values, in which we will use np dot exponential bracket input minus np dot max of input, and we define the axis as 1 and keep dims is equals to true. Next we will define the probability by getting the exponential value, dividing it by the np dot sum of exponential values, where axis equals to 1 and keep dims is equals to true, and the self output is equals to the probability values. Then we will use the loss based class. The class loss basically calculates the loss in the samples, or computes the average loss across all the samples. And here what it does is we create a function called as calculate, in which we pass the self comma output and comma y, and then we create the sample loss for across all the samples which we have got, and pass it to the self dot forward function, in which we pass output comma y. Then we get the data loss, in which we use the NP model to get the mean of sample losses. Then we return the data losses. Once that is done, we will now implement the categorical cross entropy loss, which I had shown you in the previous part of this tutorial, in which we will use the class loss categorical cross entropy loss, and then inside which we will define the forward function. We will pass self, we provide y prediction and y true, and then we get the sample, in which we get the length of the y prediction, and the y prediction clipped is equals to np dot clip of y prediction and 1 e raised to 7 comma 1 minus 1 e raised to 7. So this is basically a formula to calculate it. Then we basically we are trying to handle both one hot encoded and spare the label format. So these are the mathematical formulas which goes into calculating the losses in your sample data, so that you know how good your output will be. So using this formula and the output you get, you can then tweak your data so that you can reduce this losses. So this is one of the function which you can use to create better data outputs from your neural network. Then we define then we check if y underscore true dot shape is equals to 1, and if it is a correct confidence, then we will will store it in the value using the function ypred clipped, in which we pass the range of the sample and y is equals to true. The same thing we do if else, if y true dot shape is equal to true, then equals to 2, then correct confidence will be calculated based on np dot sum bracket y underscore pred underscore clipped into y true and axis equals to 1. So there are two different formula. In case of length of the y true shape is 1 or it is 2. Then what we do is we get the negative log of likelihood is equals to n minus np dot log of correct confidence. As we know, log of any number will create negative number. Since we want positive number, so we define the negative one, and then we return the negative log of likelihood. So this is how you can calculate the cross entropy loss in your code or in your sample or in your data, which will help you to improve your neural network. Next we create the data set. So the data set is created using x comma y is equals to spiral data, which we have defined while importing it through NNFS, which generates a spiral data set with 100 samples and 3 classes. Then we do the network setup, that is basically creating a network with 2 dense layer and corresponding activation functions, so that we get a good probability or a positive probability. So for that we define the dense layer function. You're using the layer underscore dense function, in which we pass 2 comma 3. Then we define the activation ReLU function, for the first one. After that, we define similar thing for the second layer, in which we pass the layer dense as 3,3, and then we get the activation 2 is equals to activation softmax. So we do the activation ReLU first, and then we get the activation softmax for the second layer. Next, we do the forward pass through the network. So for that, we define the dense 1 layer dot forward, in which we pass the value x, and then we do the activation 1 on the output of the dense 1 output using the forward function. Similarly, we do the dense to forward on the activation 1 output, which will be the input for the dense 2 layer, and then we do the activation 2 functions on the response of the dense 2 dot output layer. So this performs a forward pass through the network. Basically, you are forwarding all the input data from one layer to the another in this particular place. Now our next step is to get the output and do the loss calculation. As I told you in the first half, the function which we use, now we will see how in the neural network it will calculate the loss. So for that, first we do is print the activation 2 output colon 5, which means it will print the first 5 output of the network, and then it will calculate the loss and print the loss. So for that, what we do is loss function is equals to loss underscore categorical cross-entropy function we will call here, and then we will do is we are assigning the function value to the loss function, and then we pass the value of the activation dot output and also comma y to the loss function dot calculate, which is the variable which we have declared in the previous step, and then we print the output. So the total loss which we face for this particular neural network is 1.0.9844, which you will see when I run the code I run the code in the terminal, and it will show you the 5 outputs of this network. Along with it will calculate the loss. So this way you can make your neural network very stronger and better in terms of performance. So this code is a setup of a simple neural network, passing data through it and then calculating its loss. It's a basic framework for understanding how neural network operates, but it does not include training like back propagations and optimization, which would be needed to actually learn from the data. We are not showing that in this particular tutorial, but in future part of this particular course I will be showing you how to do it. Till then, keep learning. Let us know how did you feel while building the neural network, and do like, share and subscribe the channel. See you in the next tutorial of neural network. Bye bye.